All right. People will probably start trickling in, but we can go ahead and get fired up. So this talk is covering authentication as a microservice, and all my talks are interactive, so don't feel like you need to wait and hold questions to the end. Jump in at any time, raise your hand, whatever, just start talking, it doesn't matter. You can interrupt me. We can kind of get derailed and go down, paths and cover different topics, whatever you guys want to do. So it's about you guys today. All right. Just quick background on me. So my name is Brian Pontarelli. I'm the CEO of Inversoft. I started the company about 10 years ago. I've been coding professionally for about 20 years now, but I started coding when I was like 8 on an Apple IIe. So yeah, old school. But yeah, I've been doing this for 20 years, and I've worked at a variety of companies like BEA and Orbitz, yada yada. Sort of cut my teeth on really big systems. Back in the day, we were doing microservices before it was called microservices. So it was just called service-oriented architecture, and then it got rebranded as microservices. But this was even before that. All right, so in the beginning, right? So let's start off in the beginning. What I'm going to do is I'm going to go through what we used to do and sort of what we're doing now, and we'll talk about pros and cons of each. So the monolith, right? So here's a very standard example of your classic monolith. You'll have, mobile, web, doesn't matter, and it's all talking to one massive backend. All right, so here's the database backend. I just created a little to-do app as an example, but it could be anything. So in this case, we've got some users. Users might have some roles, and then we have the to-dos for each user. All right, so here's our to-dos table. Pretty straightforward. It's got text, ID, yada yada. It's got a foreign key to users. All right, so that's the key here. All right, so let's go ahead and log in old school style. And this is actually not old school. Like a lot of people say it's old school. It's not. People still do this all the time. It's fine. But what we would do is we would hit /login, and we'd get back HTML, right? And so that would be your login form. And then what we're going to do is we're going to fill out our credentials, and we're going to post. And it's going to hit the back end. It's going to authenticate against the database, make sure your user credentials are correct, create a session, and then what it's going to do is it's going to store that user object in the session and then pass back a session ID. So that normally comes back as like a cookie, right? And then you'll get a 302 redirect to wherever you're going in the app. All right, so this is a very classic pattern. So then after we have that, then what we do is we call /todos, right? That's where we got redirected to. And we're going to pass in with that request the session ID. And so then the session ID is going to be linked up by the backend. I'm going to go fetch out that user session. We're going to pull that user object out of the session, and we're going to use it to go fetch that user's to-dos and return all of that as HTML. Okay. Very straightforward. This is what our old school to-do looked like, right? So we're just doing a select on the table, and we're using our foreign key. Okay, so this works on everything. And a lot of people say is like, oh, sessions are old and clunky. And no, it works for everything. And it just depends on how you actually use sessions. But you can use them on single-page web apps. You can use them on mobile apps. You can basically use them on anything. Cookies have been around for a very long time. They're hard to steal. They're hard to forge. Like, this stuff just works. But there's some pain points with it. It's very stateful. So all of our backends have to know about sessions. We either have to have a big, huge cache, or we have to store sessions in the database and purge them. You can see that as you scale and you have thousands and thousands of requests per second, it's going to fall on its face, right? Or it's just very challenging to handle. We do a lot of load balancing. We do a lot of session pinning, right? So you'll go through a load balancer and you'll get stuck to one server. It's called session pinning. So that's a lot of the issues, as well as the big database. So the classic example I used to say is that back in the Orbitz days, we had one database for all of Orbitz. And I remember when we upgraded the server because it kept running out of RAM, so we bought 128 gig of RAM, and that was in like 2004. And it cost us almost $200,000 for the RAM. So just because we wanted to scale our single monolithic database. So big problems when you do that. Anyway, so we're ripping all this stuff apart, and we're refactoring. So this is what it looks like now. Again, simple to-do example. What I did is I went ahead and just broke out 2 APIs. So now I have a user API and I have my to-do API. This is the most basic form of microservices. You can even break this up further if you really wanted to, but I'm keeping it simple. All right, so what I did also is I broke out 2 different databases. All right, might as well make each database separate because your user database might have different semantics than your to-do database. Hence the beauty of microservices. All right, so now we refactor our tables. We have the exact same user tables in our user database. And now our to-do database is really simple. It just has 1 table for our to-dos. Right? So here's our new to-do table definition. And so you'll notice there's no foreign key. So we'll get to that a little later, but we have to decouple these things. We're microservices, so we have to break that relationship. All right, so let's walk through how we manage login with our new microservices. So first thing we're going to do is we're going to post the login, right? We're going to send that user data, and we're going to get authenticated against the database. We get our user object the same way we did before, except we're not going to create a session, right? Stateless. Let's see if we can go stateless. So what are we going to send back? Well, let's go ahead and send that user object back as just JSON, right? See what happens. All right, so now we've got a user object as JSON. It's got my user ID and my email address and my roles and yada, yada. Okay, pretty straightforward. So now I'm going to go fetch my to-dos. So I'm going to do a get to /to-dos, and I'm going to send in my user ID, 42. Sweet. Goes and fetches my to-dos, and it sends them back as JSON. Right? Pretty simple. It's just a simple API. So I'm good, right? Okay. Yeah, so obviously this doesn't work. Right? This is super broken. Because what I'm going to do is I'm going to go change. I can watch as requests are being made, just like the rest of us, right? I can see what APIs are being called. So I just figure out, oh, they're calling user ID of 42. Well, I'll just put on user ID of 1. Right? Totally straightforward. So anyone know what user ID 1 is? No. Or super user root, right? Admin. So yeah, we can totally mess with the admin of this system. That'd be awesome. I can go in every morning, he'll put in get milk, and I'll just check it off. He'll forget every day. He'll never get milk, right? So like, obviously this is super insecure, but it's sort of the first evolution of like, okay, how are we going to deal with calling these APIs in authentication? All right, so how do we fix this? So first step, we'll generate a token. So rather than passing back a user ID, we're going to pass back a token. So there's 2 types of tokens, opaque and structured. And in this case, it's opaque. Opaque meaning it's just a big, huge string of garbage. It has no meaning. It's really just a big int at the end of the day. Right? It might be base64 encoded, or it might be a UUID hex encoded. We don't care. It really is just a very, very large number. We send that back to the phone, and then when we're doing a to-do lookup, we send back the token. Okay? In order for this all to hook up, we still need the user object, because we don't know the user's ID. Right? It's not in the token. The token isn't it, because we figured out that was easy to hack. So instead, we have to create a new API on the user system in order to give us the user object based on a token. So this is called a token exchange. Give me a token, I'll give you user data. Right? Okay, so there's, happens, and a lot of people write this into their systems. And this has been sort of a classic token-based methodology when we were going service-oriented architecture and then microservices. It requires a user-to-token mapping. It's probably in the database, might be in memory, whatever. These get really chatty. So every time you're doing anything with a user, you have to go exchange the token for a user object. So it's chatty, and now we've magically coupled all of our services to one service, which is our user API. So it can be really cumbersome, right? It can be really dangerous. This is actually, this still happens in the wild. A lot of production systems have this, and it's easy. Just go look at your cookies and see if they're structured or not, and you'll know which systems have this solution versus JWTs, and we'll talk about that in a second. But yeah, I mean, this is sort of, again, a first evolution, or second, I guess, now, and it's, there's a lot of overhead and a lot of issues with it. All right, so what's the solution that we came up with? Okay, well, we said, okay, well, let's make a structured token. Let's make the token not just be a string of characters. Let's actually make it have data. So when we go and we authenticate against the user API, we created JSON web token. These are just JSON. Right? I bundle it up and I pass it back to the mobile app. And now I can use that JSON web token to call my to-do API and look the user up. Pretty simple. So these are structured, so keep that in mind. And they're verifiable. And I'll talk about that in a second. All right, so what are they? So these are just simply base64 encoded JSON. It's essentially all they are. And I'll get to the structure and how they all work, but it's JSON. So you can put anything you want in it. And some of it is well-defined, and then it's freeform as well. You can basically put any information you want in it. And the nice thing about this is they're signed. So we're going to use either a shared secret signing algorithm, like HMAC, or we're going to use a public key, private key signing algorithm, like RSA. And what that allows me to do is it allows me to say, hey, did you really create that JSON web token? And the server will give me either the shared secret or the public key, and I can verify that it was generated by an authoritative source, right? Because it's a normal cryptographic signature. All right, so here's what a JWT looks like. It's broken into 3 parts, and they're separated by periods. Okay. So the first part is called the header. It's base64 encoded JSON, and it contains some very well-defined pieces of information. The middle part is called the body, and again, base64 encoded JSON. And then the final part down at the bottom there is the signature. So that's either an RSA or an HMAC signature. And that's what allows us to take this JWT and verify that it came from a correct source and hasn't been hacked. So this basically becomes our portable unit of identity. All right, so here's what the header looks like. If I base64 decode that. So I have 2 claims in there. I have no idea why the people that wrote the specification insisted on using 3 characters. It's like they were stuck in like the 80s and like, Unix systems or something. But all the defined claims in the specification are 3 characters. So the first one is type. This is a JWT. Oh, sorry, that's another thing. The specification defines how it's pronounced. You pronounce JWT, JWT. So. And then in the algorithm. So in this case, I'm using RSA, public key, private key, with 256 hash. Okay, so here's the body. Again, base64 encoded JSON. If I decode it, I have a couple of well-known claims. So the first one is called issuer. That's basically the thing that generated this JWT. Expiration, number of seconds since, January 1st, 1970. And that's the instant that this thing expires. So remember, we took all the bytes from the JSON and then we signed them. So once you create a JWT, the expiration can't be changed. So it has a very different semantic than sessions. So just kind of keep that in the back of your head. If I have a JWT, it will expire. It's not a sliding window, which means every time you touch it, it gets extended like a session does. It doesn't work like that. It has a very definitive expiration instant, and that's defined inside the JWT, and it's required. The audience, that's essentially who this is intended for. Usually that's like an application ID or a client ID. The subject, who am I? That's my user ID. And then the last 2 are just totally freeform. I just made them up. So I put in my name and I put in some roles. So this is awesome. So now I can actually put in my roles for this audience, and the application can actually verify that those are valid and then use those in code, right? So I don't have to go back to another system and say like, hey, give me the user's roles. It's all part of the JWT. So we can start stuffing roles and other authorization information inside the JWT. So again, pretty powerful. All right, and then here's my RSA signature. Just base64 encoded garbage. All right, so here's what the new to-do looks like. The to-do select. So I'm selecting from the to-dos table, and then I'm using the ID that I got out of the JWT. I don't need to go back to the user API. I don't need to make sure that this JWT is good. I don't need to do any of that. I just grab the ID right out of it, and I use it for a select. And you can pass these JWTs anywhere you want. You can send them to your neighbor. You can send them over here. You can put them in the server to store them in the data. It doesn't matter. They're totally portable. All right. So we can look at a little bit of code. Let's flip over to IntelliJ. All right. So let's take a look really quick. We can look at a couple of things, but let's look at our authentication and how we're going to actually, authorization, how we're going to actually call a to-do API and determine whether or not this user is allowed to make that request. And then get the user ID out of that JWT and use it. Okay? So here's a route. Sorry, it's Node. I know some people hate Node. I particularly am not a huge fan, but this is what we wrote it in as an example. All right, so this is a route. This is an express route inside Node. And it's just a slash to-dos, exactly like I showed before. And the first thing I'm going to do is I'm going to decode the JWT. All right, so I'm going to come in here and I'm going to decode my JWT. And so we stick our JWTs in an authorization header. So it comes in the HTTP header. Pretty straightforward. Most people do this. The only difference that we tell everyone to do over what most people are doing currently is that for the authorization scheme, we don't use bearer. Because bearer is a little innocuous, right? You don't know. It could be, it could be a SAML token. It could be a Kerberos ticket. It could be an OAuth token. It could be an access to. You don't know what it is. So we're like, okay, well, why don't we just tell you what it is? It's a JWT. So we use the JWT prefix or the JWT schema. So some people recommend that you do this. Others say, no, use bearer. I'll leave it up to you, but we like JWT. It's well defined. And then we just decode it. So the decoding function is pretty straightforward. I'm going to split it on period. I get 3 parts out. If I don't, I'm going to freak out. I grab my header, base64 decode it, grab my payload, my body, and then I do a couple of checks. You can ignore this code. I'll get to that later. And then here's where I do the verification. So in this case, I have an RSA, public key, private key. In this case, I have my public key, so I'm going to grab it out, and I'm going to verify that the JWT is valid using that final piece of it, which is part 2. And these are all open source, libraries. You can go grab them. All right, so if it's verified, I'm going to go ahead and decode it, check my expiration date down here. I might do a not before check. This is another well-known claim. You can say this JWT will be good later, not before. And then when I'm done, I return it. So pretty straightforward. It just comes back as JSON, as a JSON, just an object in JavaScript. So if I hop back out, okay, that was my decode method. Hop back out again. So in this case, what I'm going to do is I'm going to use the JWT to see whether or not this user has a specific role. Can he retrieve his own to-dos, right? I don't know, stupid role, but whatever. It's fun. All right, so I hop into that. And this is where I can go ahead and I can check, my roles. And we can do a bunch of stuff here. But this is the key lines of code right here, like those 3 lines. That's where I'm checking my role. So because I've trusted the JWT, I verified that the signature was accurate. It's RSA signed. I'm good. Then I can trust those roles. I know they were generated by the identity manager, the person, the place that you logged into. So that's it. And then now that I'm done, I'm good. I can use my decoded JWT. I can get my subject out, and I can go retrieve my to-dos right there. Any questions thus far? I'm just going to keep firing away. All right. Let's keep rocking. All right, so there's a couple of JWT hacks. Yep.
Where did you start the token? This was like you got the token and there was a queue.
Yeah. All right. Yeah. So this application, the question was, where did I store the token? Where is it? In this case, the app was storing it in local storage. There's a couple of things that people have started to bring up with local storage. They say it can be pretty dangerous for tokens. These are signed. They're hard to manipulate. So I agree local storage can be a little dangerous. Like somebody could take your JWT and then start calling APIs on your behalf. So a cookie is usually the best way. So just use an HTTP only cookie so you can't access it from JavaScript, and then you're fine. Because then you get it for free. Every time you make an API call, you get your cookies sent across. Right. Another thing, I have another talk, not today, but you can find it online or you can email me and I send it to you. And that's all about like API gateways. And so how do you front things so that you can do a lot of this authorization and authentication on the front side rather than having to do it in every single API. So I can talk about that as well afterwards if you guys want.
Okay, I have a question.
Yep.
Based on the tokens, do you just validate the username or also the password?
Oh, all right. So when the first time you're authenticating, right, you're logging in. So yeah, so you're going to basically collect whatever data you need for your backend. So in most cases, that's going to be an email address and a password. Some people might use like an RSA certificate. You can use another ticket from another ticketing system, right? Or you can use another exchange token. So like you might say, hey, I have this token from Google. Can you use it? And it'll say, yep, I got it. Thanks for the token. And it'll exchange the tokens. So there's lots of ways to authenticate users. The most classic one is just email and password. Yep. All right, so the classic hack that, oh, yep.
And this token to be used across different applications?
Sort of. So there's always an exchange that goes on between applications. So a JWT is defined by 3 bits of data, sometimes 4. The person it's for, the application it's for, and the device it's on. So if you have a JWT for, let's say, your website, and you want to take somebody over to the forum, you need to exchange it for a JWT for the forum. So usually there's an exchange process. So like in our case, we have an API called /API/JWT/exchange. You pass in a JWT for one app and you get a JWT for another. And the only reason you do that is because you want to know the roles for that user in the other app, right? So, any other questions? Good questions. All right. Everyone complained when this first came out about how insecure it was and don't use JWTs, they're horrible. And really the one main hack that everyone sort of dreamed up, which is not really reality, was what we call the none algorithm hack. So JWT specification allows a none algorithm. So if you remember in our header, we had alg, and then RSA, 256. You can just say none, and then you don't need a signature. So here's the hack. I take my original JWT, I strip off my signature, I decode the header, and I change algorithm to none. I encode my header, and I jam it back in. Okay, this is a valid JWT. Totally valid, according to the specification. And then what I can do is I can just take the payload and the body and I can change whatever I want. Use different IDs, I can give myself whatever roles I want. All right, so this is always the one that people complain about. So there's an easy fix, right? Just don't allow none. Genius, right? So every implementation I've ever seen, the first line of code is like, if algorithm equals none, error. So it's one if statement. Okay, there's one other one that has come up recently. I don't think it's ever been exploited, but it's possible. And what it does is it allows you to flip the semantics between RSA public key, private key, and HMAC. And what you can do is you can actually take the public key, which is well known and published. Like right now, I can go get Google's public key. It's just, there's a very well-known URL. It'll return you the public key. I can get Facebook's and Twitter's and everybody's. What happens if I took that public key and tried to fool the server into thinking it was the HMAC secret? And so it looks like this. All right, so here's our JWT. All right, so if you see, I have my algorithm as RSA, and I have this public key. Okay. I'm just going to go ahead and I'm going to flip the algorithm to HMAC instead. Now, if the server is dumb enough, to say, okay, well, I have this key that I've been generating things with, and maybe I'll just use that as the shared secret. Yeah, that'll work. And if it'll actually verify the signature using the public key, you can exploit the server. You can basically fool the server into thinking that the bit of information that's publicly known, which is the public key, is actually a shared secret. I don't think this has ever happened in practice, but it is one exploit that people sort of have mentioned as possible. And the easy way to fix it is just don't be dumb when you look up your keys. If you're going to look up a key, make sure that you store the type of key it is. This is an RSA public key. This is an HMAC secret, right? So then when you get an algorithm that says HMAC and you're like, no, that's a public key. I'm not going to use that. Simple, fixed. So just be smarter about your keys. All right, RSA verification. So this is the most common method. This allows me to generate a JWT and send it anywhere in the world. I can share my public key with anybody, and they can use it to validate my JWT. They can also use it to exchange it for one of their JWTs. And this is a classic way that like Facebook, Twitter, et cetera, LinkedIn, everybody's moving to this as a methodology for OAuth, for federated login, right? Which essentially means go over there, log in, come back with a little bit of information that is verifiable, like a JWT, and then I'll use that to set you up in my system. All right, so it looks like this. So this guy down here, the to-do API, needs the public key. He needs to be able to verify that that JWT was signed by an authoritative source. So I can just drop it in a file on the hard disk, and he can just load it up and just use it, right? So that's one way. That sucks if the key changes. You got to go bounce all your servers. So instead, what a lot of people do is they just write a little API. And then you can go ask your user API, hey, I'm starting up. What's the public key? And just download it. And so the API might return something like this. So it just returns your public key. And then you can just use that public key to do validation, to do key verification. Okay, this comes up quite a bit. What happens if I have multiple keys? Like a lot of people will rotate keys. So they'll keep the last 3 keys in rotation, add a new key like every couple of months, and then take the last, the fourth one and drop it off, right? So you slowly rotate your keys over time. Well, that's going to require you to tell the JWT validator which key to use. So what the spec says, it says, go ahead and add this little header called KID, which is your key ID. And instead of returning one key from the API to get the public keys, you return multiple keys, and that's just a hash. So 42 is the one that I specified in my KID, and then 42 is that public key. So now I can have multiple public keys, and they just have a unique identifier. So simple. And then when you're going to do your verification, you just look it up from the hash, and you say, oh, I'm using that key. I'm using key 42. Any questions on that stuff? All right. I got a ton of information. We can keep rocking. Let's see, what's my time? Oh, got plenty of time. Crazy. All right, so refresh tokens. Remember that JWTs are short-lived. They're only designed to last for like minutes. I mean, hours are long. Refresh tokens, on the other hand, are designed to last for a very long time, like days, weeks, months. So who here has Google, like Gmail, right? Everybody, pretty much? All right, anyone have MFA turned on, 2-factor? Hopefully everyone, all right, everyone go home right now, or get on your phones immediately, and we're going to take a break while you guys do, turn on MFA. Just do it. It's almost a requirement now, especially for folks in our field. Just go in, it's super easy, just turn on MFA in Google, and it'll push you a code. So if you don't have MFA enabled, and does everyone know what MFA stands for? Sorry, I'm using acronyms. Multi-factor authentication, right? Okay. So if you don't have it enabled, Google will leave you logged in basically forever. Like, you'll never have to re-authenticate as long as you keep your browser open or you don't shut your computer down or anything like that. The second you enable 2-factor or MFA, you get about a 2-week window, and then eventually Google will kick you out and say enter the code again. So it's kind of annoying, but it's going to save you a headache if your account ever gets hacked. So the way that everybody does this is through refresh tokens. So what I'm going to do is I'm going to generate a big opaque token. It's not going to have any data in it. It's just going to be a big mess of garbage. I'm going to hand it back to you. And then what you can do is you can use your refresh token to create new JWTs. So it looks a little something like this. So after we authenticated and we push the JWT back to the mobile phone, that little gray circle behind the or on top of the user is the JWT. And then I generate another token. And it's hard to see. I'm sure the back is really small. But I generated a new token called the refresh token. And so the user API has to store it somewhere. But then what I do is I push that refresh token back to the phone, and the phone can store it. All right, so refresh tokens need to be extremely well secured. These are basically you. If anyone gets your refresh token, they can generate JWTs for you until it expires. Weeks, days, months. I mean, who knows? It could be a very, very long time. So if you're building an app and you're implementing refresh tokens, make sure they go into secure storage if you're doing, any form of mobile. Cookies are okay as long as they're, JavaScript-less cookies in a web app. Just secure them as much as you possibly can. All right, so this is a funny story. So I wanted to make sure I spelled revocation correctly. And so when I came up, I found this death metal band. And then I was giving this talk in Denver like 2 months ago. And this dude comes up and he's like, dude, Revocation is playing tonight down the street. I was like, you're kidding. I'm like, we're going. We're totally going to see these guys. So yeah, not the death metal band. It's /logout, right? So how are we going to manage logout? So all we need to really do for logout is we need to revoke the refresh tokens. So when we log out, we're going to add a new logout API to our user API, our user system. And when you call it, all I do is I delete your refresh tokens. Because that's really all I care about. I know the JWTs are going to expire because they're short-lived, only a couple of minutes. All I care about is that you're not allowed to use the same refresh token to keep getting more JWTs. Right, so you just kill all the refresh tokens. Make sure that you have a really large sort of kill all for this. Because the worst thing that's going to happen is that, let's say there's a breach. You want a big kill switch and you just hit it, and it basically logs everybody out, shuts everything down. So yeah, the users have to log in again. They might be annoyed, but at least that breach wasn't escalated. So we always tell people make a big old log out everyone button. And you might want to make sure that the person who's going to hit it has the right permissions to do that, but just make a big logout button. All right, so let's talk a little bit now about deleting users. All right, so we've covered JWTs, and you remember that we broke the link between the user table and the to-dos table. All right, so we don't have that link anymore. So I'm going to go delete this user. Totally fine in the user database, but I don't have my cascade on delete anymore. Oh, bummer. So we're going to have to handle this some way. So one way that a lot of folks have dreamed up is the global delete. So you basically make an app that calls every API in your entire system and calls delete on it for a specific user. It works. It's a little brute force, and every time you write a new API, you got to make sure you implement that delete system. But, whatever, it works. There's another way. You can start generating events, right? So your user API can fire an event that said, like, hey, this user's been deleted, and it gets broadcast out. It could even go on a Kafka topic, right? You just blast it out, and everyone listens for it, and then they take it, and they run with it. So let's look at that. All right. Now I got to pull it up. Hang on. Remember my keystrokes. All right, so let's take a look at our webhook. All right, so here's my webhook. Can everybody see that? It's a decent size, not great. Oops, lost it, sorry. All right, so first things first, you're calling a webhook. Make sure whoever's calling you is authenticated. They have access to actually make this invocation because you're deleting data in this case. So you better have like an authorization header or a certificate or something. Because otherwise somebody hacks your webhooks and boom, like I can wreak havoc. Like, you give me 30 minutes, I'll delete everything in your system. Right? So be careful with these things and really implement security on your webhooks the same way you would implement security on any other part of your APIs, especially your user APIs. So in this case, I'm checking my super secret authentication key of API key. If I don't have it, I'm just going to say, okay, 403, get out of here. If I do have it, we have a couple of different types of events. Let's look at the second one first. This is our user delete event. So that is an event that's going to come from our user API and tell us that a user was deleted. The body of that event is going to have the user ID. Right? So once I have the user ID, I'm good. I delete his to-dos. So pretty straightforward in terms of the way that we're going to allow these services to be orchestrated. Now, if you want to get real crazy, you can implement transactions around this. So what you can do is you can say, okay, I'm about to delete a user from the user database. Before I do that, I'm going to start a transaction, call all my webhooks, make sure they all succeed, and then I'm going to commit the transaction. If any of them fail, just roll back the transaction and allow the user to try to be deleted again, right? So all of your webhooks should be safe against multiple calls. At any time, they should be able to handle invalid data that comes in, or old data. So keep that in mind. All right, let's go on back here. All right, so one of the classic questions that always comes up. Can I revoke JWTs? Sorta. Not really. So remember, JWTs are designed to be portable units of identity. They're not designed really to be like stored in the database and managed by your identity system, your user API, as I call it. But there's kind of some cool little hacks that we've come up with to make this possible. So here's what we sort of devised, and it actually works. I'll show you in a second. When you log out, what you do is you delete all your refresh tokens, right? Well, what happens if I fire an event out to all my other systems to say, hey, this specific user has had a refresh token revoked? Those other systems can watch for that event, and then they'll know that certain JWTs are now invalid because they were generated at a certain point in time. All right, so let's assume, I haven't updated this for a few months, sorry. Let's assume it's November 9th, 2017 at exactly 1:12:47 p.m. Right? We know our JWTs that was just created, like just now, will expire in exactly 30 minutes. So it'll expire at 1:42. If I created a JWT 1 second ago, right, it'll expire 1 second before that. So 1:42:46. Okay, therefore we can say all JWTs that have an expiration that's before this instant are now no longer valid, because we know the refresh token that was being used to generate them is no longer valid. Right, so it's all time-based, and it looks like this. All right, so, again, I apologize. This says 6. They should say 1. So 1:12:47 to 1:42:47. In this case, it's 6. Everything in the red is dead. So if I created a JWT at any point in the, if any JWT has an expiration that's in the red, it's now garbage, right? Because we know the refresh token that was used to generate them is toast. Everything in the green is good, and everything in the blue is already expired, so we don't care. Make sense? Bring it? All right. All right, so let's take a look at how to implement this, because it's actually really, really simple. Very few lines of code. All right, so here's my event. So I have my jwt.refreshToken.revoke event. So I know the thing that's coming in is the duration of my JWTs, because that'll give me my window. So I know right now, to some duration, is going to be invalid. I'm trying to build that red line. So I grab that information from the request, and then I just wrote this little JWT manager, and I can say revoke. So for this user ID, 42 or whatever it might be, I'm going to revoke his JWTs. So this is, again, pretty straightforward. So I have a big hash. It's static. It's global. And it says, for this user ID, here's the duration, here's the cutoff, which is that last little part of that red line. Everything after this is okay. Everything before this is bad. Make sense? All right, let's go take a look at our to-do again. Yep.
For revocation, you are filtering out based on timestamp.
All timestamp based.
So that as opposed to actually storing revoked or
Yes. There are a lot of folks that sort of have said that let's store refresh tokens and JWTs in a revoke cache. And that's another possible solution as well. It requires a little bit more scale depending on how you go about it and like how you want these things distributed and who has access to the cache, you know, et cetera, et cetera. But yeah, it's absolutely, it just requires storage, right? You have to store all these tokens then. So, yeah.
You see some audit trail.
Yeah, they both can give you audit training. At any point in time, you can just write your audit log and just basically say like, this thing will go. All right, so let's go back here. We decoded our JOT. We wanted the JWT to code. And then down here, I believe it's here. Nope, sorry, wrong spot. Oh, authorize, yep. Okay, so in my authorize, I've decoded the JOT. I've verified its signature is correct. I now have a valid JOT. Now I just need to figure out if it's been revoked, you know, quote unquote. So what I do is I actually go into that JWT manager that's storing our cache of a revoked instance and cutoffs, and I just ask if it's valid. So I grab the subject, which in this case is the user ID. I see if they have an expiration instant, and if they do, if that JOT is before now, it's bad. If it's after that instant, it's good. So again, that's the part of the red line, right? Everything before is bad, everything after is good. So that's what this check is doing right here. Pretty simple. All right, let's see it in action. How much time do we have? 5 minutes-ish? 10? All right. All right, I have to re-log in. All right, so I'm going to log into this little example. This is my to-do app, the one that we've been looking at. We built it for IBM, and I keep forgetting to change the logos. And then I'm going to log into our IDP, our user API, right? So this is our user API interface. All right, so here we go. So now I'm into John's account. So John's logged in over here, John Doe. All right. If you notice that I have down here a section called sessions, really what that means is they're just refresh tokens. So there's just a list of all the refresh tokens for John. What I'm going to do, if all goes according to plan, nothing, you know, it's not a real presentation unless your demo messes up once or twice, right? All right, so I'm going to delete my session. Okay, refresh token has been deleted. If I flip over to my terminal, down here, I should get a little message here that says revoking JWT for user for this many seconds. I don't know if you can see that's really small, I apologize. So I got that call from or into my webhook, and then I wrote it into my little cache. So now if I flip back over to my web browser, I'm in my to-dos, I hit refresh, and I'm logged out. Right? Because I know the JOT that I had in my browser stored in a cookie had an expiration instant that was invalid. It hadn't expired, it was just invalid according to my little cache. So if you're building like highly distributed systems, you're dealing with a lot of APIs, firing off these events and storing these caches is actually pretty simple to do. And it allows you to do orchestration without a lot of data flying around your network to validate these things. Because the worst thing you want to do is every time you go call an API, you don't want to be constantly calling back to the user service checking if these things are valid, right? Because it defeats the purpose of JWTs, which is to decouple everything and reduce your network chatter. So.
But will I be able to find last log taken to an account, to the system, in the last 1 hour,
Yeah, if you design your system right. I mean, you store, you basically...
In an example, now that we deleted the token, will I be able to know that this specific user, I don't remember the name that he used, but will I be able to know that this specific user has logged into the system?
Sure. Yeah, so in our example, what we do is we store a log of logins. So we store those separate than refresh tokens and JWTs. Because this is an audit trail, so like depending on where industry you're in, you might be regulated by these things. Storing logins is also a really valuable piece of data, right? So we actually store all logins for all time, which for some clients is really big. Yeah.
Question. If there's no explicit action of logging out, you just close the browser window, so your past expiration
Well, all right, so the question was, if the user closes their browser and, you know, basically like inherently is logged out, how should we get rid of the refresh tokens, right? Well, it depends on if it's a cookie, and that cookie gets purged when you close your browser, because then your refresh token is just magically gone, and then you can't do anything, you have to log back in, right? So that's one way to do it. The other way is you don't want to. Because in the Google example, or Facebook, or yada yada whatever, you can persist cookies across logouts, and you can use those refresh tokens to log back in. I don't suggest it, but you can.
That makes me terribly apprehensive.
I don't disagree with you.
What would your implementation be like? I mean, if
Yeah.
you wanted it to be secure.
Our implementations are always delete your refresh tokens on browser close. And actually, if you have an app close event, delete a refresh token. Because the worst thing that's going to happen is the user's going to log in again, right? So an API call to delete a single refresh token on our system is really fast. Like we can get like 25,000 of those per second. So you can fire it asynchronously too. Because it's a single refresh token per single. I mean, there's lots of ways to do it, but that's one of them. And so yeah, we do close events, and we just call we have /API/JWT/revoke, and you pass in either the token itself or the user ID, in which case it deletes all the user's refresh tokens. So, all right, where were we? All right, a couple of other things. So when is a user logged in? All right, so this is kind of an important thing to reconcile depending on how your application is going to work. So what happens if the user logs in and you're forcing them to change their password? Are they really logged in? I'd say no. Some people say yes. It's up to you, but in my mind, you should force them to update their password before they actually can log in and use the app, right? Because it's a security thing. So in order to handle that, you might need to implement a system whereby you can have users in a partially logged in state or a non-logged in state with a token that they can use later to auto log in. So it kind of looks like this. So you would post to the user API again. We validate that they are in the database and everything's good, but we notice that the system is saying that they require a password change. So we don't want to send back a JWT, because once you have a JWT, all bets are off. You now have access to any API that takes a JWT. So don't send back a JWT. Right? Instead, what you can do is you can pass back a huge big ID, some monster ID, and you can use that later after they've changed their password to log them in. Or if you want to be real nasty and peeve your users off, after they change their password, force them to log in again with the new password. So lots of options. So this is how it looks. So after I change my password, I exchange my ID for a JWT, and then I get a pushed JWT back to the app. All right, two-factor, right? This is a big one. You're logging in, and you have MFA enabled. And should you be logged in? So no, right? Because MFA is actually the login. The first part of it is login kind of, but not really. It's just like, are you sure you are who you say you are? Okay, now you can log in. Like, yes, okay, I've authenticated that you're in the database with a password that you might be the only person that knows, or it might have been leaked and you might have been breached. Then I'm going to actually allow you to log in, hence the two-factor, right, or the MFA. So similarly, post to login, hit the user API, we authenticate them against the database, and we say, yes, you're you, or at least you're someone who has this, who knows your email address and password. So we don't send back a JWT. Then we do a push out to our push, or we do an API call out to our push service. It pushes a code to our phone. And so now the phone has that ID that we sent in. Again, usually these are just huge strings of data, right? They're just big opaque tokens. So the phone has our big opaque ID or a big opaque token plus the MFA code. I push both of those back to the user API, And the user API validates both pieces of data and says, yep, okay, now you're really you. And it logs you in and it returns a JWT. Make sense? Okay. All right, what happens if your email is not verified? So this really depends. You can log them in with a limited set of roles. You could not log them in. And, yeah, go ahead. Yeah, am I over? I'm probably over, but that's fine. So anyway, same system. You can decide whether or not you want to send back a JWT. You might send back a JWT with no roles, and that's what a lot of folks do. So that's it. Thank you for coming. If you guys have questions, come up and see me. I can stand outside if somebody's going to use this room afterwards as well. So thank you.